Math 31, welcome to example 5. So let's see what we got. It says, suppose that an arithmetic sequence has its sixth term equal to 9 and its fifth term equal to negative 36, and it wants me to find the first term. Okay, I see arithmetic, right? And we go, okay, we know there's a D value. I see sequence, and I know there's a list of numbers. Okay. So then let's try and piece this together. I should mention, once you see arithmetic sequence, you know this formula is in play. So anytime I hear arithmetic sequence, I'm like, all right, there's my formula. I can use that. There are 4 variables, right? A sub n itself, the first term, n, and d. And the most critical components of this are a sub 1 and d, right? And I wasn't given any or either of those, right? I wasn't given a sub 1. I'm being asked to find it. I wasn't given D, so we have some work to do. At best, I can see I was given maybe n being 6 and a sub 6 being 9, but that's still not a sub 1 and D. I also, in another sense, if I want to use this number, I know n could be 15 and a sub 15 could be negative 36. But still, even if I'm plugging in n equaling either 6 or 15, and then here either 9 or negative 36, I have two variables missing. So there's got to be another way to find D. And I say D specifically because once I find D, then I can find a sub 1. And I know I've been rattling on for a while, but let's think about the relationship between a sub 6 and a sub 15. So I want you to think how this would work. I'm going to create a sequence of numbers, and I'm just going to separate this for a moment. I want you to think if you had a sequence and you went from a sub 6 to a sub 15, that means you have a list separated by commas. And let me just write this out for a moment so that we can get a visual. Oh, I might run out of space. Can we see all of this? Can you see a sub 15 right here? It looks like it. Great. I just made it in. Okay. So I want you to think, how did I get from here to here? Well, because it's arithmetic, I'm adding a D each time. So from here to here, I added a D. From here to here, I also added a D. So I want you to think about how I get all the way from a sub 6 to a sub 15. And let me just draw all of these arrows and these plus D's in. All right, and let's count this up. I would have added 1 D, 2 Ds, 3, 4, 5, 6, 7, 8, 9. So to get from a sub 6 to a sub 15, I had to add 9 Ds. And if you're thinking, well, how do I know it's the number 9? Think about the subscripts. If you took 15 minus 6, that is 9 Ds. So what I'm saying here is I know a sub 16, a sub 15, my bad. A sub 15 has to be equal to a sub 6 plus 9D. Right? That's what this is telling me. So let's work that formula for right now. I'm going to keep this off to the side here. All right. Actually, let me move this formula over here so we can see this play out in order. All right, so here I'm going to solve for D. So I know a sub 15 has to equal a sub 6 plus 9D. We knew a sub 15 was negative 36. We knew a sub 6 was 9. And then we have this 9D shenanigans. All right, so I will subtract 9 to this side. Negative 36 minus 9 is going to be negative 45. So I know 9D is equal to negative 45. When I divide by 9, I'm going to get D is equal to negative 5. Again, critical piece of information, okay? And then I'm going to use that in this arithmetic sequence formula. All right, so now keep in mind, my goal, my end goal here is to find a sub 1. Okay. So let me keep moving these little pieces off on their own. All right. So from here, once I find that, I'm going to say, well, I could use either a sub 6 or a sub 15. It doesn't matter. I'm going to use a sub 6 just because it's a smaller subscript. So I know a sub 6 will be equal to a sub 1 plus 6 minus 1 times D. So I know 9 will be equal to whatever a sub 1 is plus 5d. So 9 will be equal to a sub 1 plus 5 times negative 5. So 9 will be equal to a sub 1 minus 25. And when I solve for a sub 1, when I add the 25 over, I'm going to get 34. All right. So you see me manipulating all sorts of stuff to get here. And let's just take a pretty large zoom out. When you hear arithmetic sequence, you're going to use this formula. All right. The most critical pieces of information are a sub 1 and d. Those are the two pieces of information that you really need moving forward, or really need when you're manipulating this. Now, I had to be able to find d by knowing that if I started at a sub 6 and I added 9 of those d's, I would end up at a sub 15. So a sub 15 is a sub 6 plus 9d. I can plug in negative 36 for a sub 15. I can plug in 9 for a sub 6. And you saw me get to d being negative 5, which is a critical piece of information. So then I take that d being negative 5 and I plug it in here. And I use the fact that if you know a sub 6, right, you know n and you know a sub n. And if you had d, that means you had the d variable, you had the n variable, you had the a sub n variable, and you can solve for a sub 1. Because in this arithmetic sequence formula, there are 4 variables, and most of the time you're given 3 and need to solve for the 4th one. So I was able to kind of back into finding a sub 1. You also could have counted it out, right? As soon as you find d equaling negative 5, you can work yourself backwards and say, well, the term before a sub 6, right? I would have known a sub 5 here had to be 14, because 14 minus 5 gets you to 9, but you can add 5 to work yourself back up. I just think it's always more efficient to use the formulas in case these subscripts are really, really large numbers. All right, so with that, we're going to take a look at example 6. It's just a slight graphical approach to these arithmetic sequences. All right, I'll see you in a few. Bye.